Hello everyone, my name is Xiaoyi Lu from the Ohio State University. Here I'm going to present a tutorial of how to run MPA programs on Chameleon Cloud and show demos of using MRP2-based complex appliances to deploy MPA bare metal and KVM with SR-IOV clusters. This tutorial was prepared by myself and my colleagues. They are Jie Zhang, Shanshan Gugani, Dr. D.K. Panda from the Ohio State University. So this is the outline of the presentation. First, I will give an overview of MRP2 appliances we developed on Chameleon Cloud. And then, based on these appliances, I will show a demo of deploying MPI bare metal cluster with Infiniband, and another demo of deploying MPI KVM cluster with SR-IOV enabled Infiniband. And then I will show some examples of how to run MPI programs on Chameleon Cloud, and then I'll conclude the presentation. As you may already know, Chameleon is an NF-supported cloud which provides users a powerful and flexible experimental instrument. Chameleon Cloud has a large-scale test bed which can help users to target big data, big compute, big instrumental research. Chameleon Cloud has around 650 nodes and 5 PB disks over 2 sites, and these 2 sites are connected with 100 gig network. Chameleon Cloud can provide users bare metal level reconfiguration, and it also gives users the root permission so that users can do all different kind of configurations on Chameleon Cloud platform. Chameleon Cloud has a lot of partnerships with other production clouds such as CERN, Google, and many others. For more information about Chameleon Cloud, please go to this link, and you'll get more information from there. Our OCU team has developed 2 MPI complex appliances based on MRP2 on Chameleon Cloud. So if you go to the Chameleon Cloud appliances web page, you'll see that there are 2 appliances, as the red box indicated here. First one is MPI bare metal cluster complex appliance. Users can use this appliance to deploy bare metal MPI clusters using the MRP2 library of Infiniband. And then the other one is MPI plus SR-IOV KVM cluster complex appliance. Users can use this appliance to deploy MPI cluster of KVM virtual machines using the MRP2 Vert library and SR-IOV enabled Infiniband. So before I go to demos, I want to first introduce MRP2 project. MRP2 is a high-performance open-source MPI library for Infiniband, Omnipulse, Ethernet, IWAP, and the Rocky networks. MRP2 project has been available to the community for almost 15 years already. So not only for the MRP2 library for MPI programming model, we also have other variant libraries. For example, MRP2X is designed for MPI plus Pegasus hybrid programming model. MRP2 GDR is designed for GPU accelerator. MRP2 Mic is designed for Intel Mic architecture. MRP2 EA is designed for energy-aware scenarios. And there's one library we want to highlight here is MRP2 Vert, which is based on MRP2, but it has many optimizations for virtualization environments, so that users can run MPI jobs in virtualization environment easily and also get near to native performance. These libraries have been used by more than 2,675 organizations in 83 countries, and there are more than 400,000 downloads from the OCU site directly. Many top 500 clusters are using the MRP2 libraries. For example, TaxStampy. Through this link, you can get more information about this project. You can also download all these libraries and try on your cluster. Okay, first I will give a demo of deploying MPI bare metal cluster with Infiniband through our appliance. First of all, you need a Chameleon Cloud account to log into the Chameleon platform. So once you log in, this is the dashboard of the Chameleon Cloud. So first of all, you have to create a lease, which means that you need to reserve a set of nodes to do the following experiments. So there's a button called Create Lease. If you click this button, you will go to this form, In this form, you need to input all necessary information to create a new lease. For example, what's the name of the lease, and when this lease will get started, and when this lease will be expired, and what kind of resource types, what's the minimum number of nodes you want to reserve, what's the maximum number of nodes you want to reserve. And then there's important information you need to give is that what type of nodes you want to reserve. So if you want to run MPI applications on Chameleon Cloud, we strongly suggest you to reserve Infiniband support nodes because these nodes will give you the best performance for MPI-based applications. And then after you click create, the lease you just created will be shown here. Here we create a lease called ZJ-16-IP, where we will use this lease later also. Okay, now this demo is for deploying MPI bare metal cluster. So in the in the Chameleon Cloud Appliance web page, you need to select MPI bare metal cluster complex appliance. If you click this appliance, you'll go to the detailed description of this appliance web page. So there's an important button called get a template in this web page. So if you click this button, it will show you the detailed configurations of this appliance. You don't have to go to this configurations line by line. You just have to copy this URL, and this URL will be used later. Okay, the next step is to launch stack based on the complex appliance you just selected earlier. Okay, there's a button called the launch stack in the stacks web page. Okay, if you click the launch stack button, there in the drop down box there are different ways of getting template source. So one option is through URL. So if you select URL and then paste the earlier saved template URL to here, then click next, the system will automatically interpret the template file and construct this form for you. So here this form is very simple. You just have to give a name of this stack you want to launch, and then the password of the user, and also you need to select the SSH key you want to use when you later on when you try to log into the instance. So, and also how many nodes you will be used to launch this stack, and then what lease ID you created earlier, you need to select here, and then you can create a launch. So here give example, we create a stack called MPI bare metal. Okay, we put the password here, and we already upload our SSH key into the system. So here we just have to select the SSH key, and then we say that we will launch 2 nodes, and then this is the lease ID we created earlier, and then we click the launch. Okay, and then the system will show the stack we just created. The name is MPI bare metal, and the status shows that this stack is being created. Okay, if you click the MPI bare metal stack, this shows the detail of this stack. Okay, so this is the steps of deploying MPI bare metal cluster with Infiniband. So it's very easy. You just have to use our appliance, and all the configuration steps and the installation of MPI will be automatically handled by our appliance in the background. Okay, the next demo is to show that how to deploy MPI KVM cluster with SR-IOV enabled Infiniband. In this demo, basically we are assuming that users want to deploy KVM virtual machines in bare metal nodes and also run MPI jobs inside virtual machines. So again, you can go to the Chameleon Cloud Appliance web page. In this web page, this time you need to select MPI plus SR-IOV KVM cluster complex appliance. If you click this appliance, this web page will show you the detail of this appliance. And again, you need to click Get a Template button here, and then you'll get the detailed information about this appliance. You don't have to go to details of this configuration line by line. You just have to copy this URL, and this URL will be used later. And then again, you go to the stacks web page and do the launch stack, and then you put the URL. You just copy it, and then the system will interpret the template file automatically for you, and then construct this web form. In this form, you need to again put the name, password, select the SSH key. Things in this complex appliance will deploy the virtual machines inside the bare metal nodes, so you have to give some necessary information of the virtual machine configuration. For example, what's the memory size for each virtual machine? Here we give 4, means 4 GB memory will be configured for each virtual machine. And then the reserve ID means the lease ID, like earlier we created for the lease. And then how many total physical nodes you want to use, and then total virtual machines you want to deploy, and this virtual machine will be deployed on this total number of physical nodes. And then for each virtual machine, how many virtual CPUs you want to configure. Here we give 2, means 2 virtual CPUs will be set up for each virtual machine. And then if you click launch, the 2 bare metal nodes will be deployed. And then the status showing that these 2 instances are being spawned. Okay, so through these steps, you already ask system to deploy MPI KVM cluster through our appliance. So the system and our appliance will automatically deploy the environment for you. You just have to wait. Okay, then the next step is how to run MPI programs on this environment. So the first thing is you have to wait until the stack gets successfully deployed. So the status showing that the now is running. Okay, as the blue box shows that our appliance will automatically assign a floating IP, which is a public IP, for the first instance in the stack. For example, here the MPI instance 0 will get a floating IP here. Okay, so you just have to copy this IP address and then open a terminal and then type SSH CC at this IP address. Okay, and then you will log into the MPI instance 0 node without input password, because like I said earlier, you need to, when you create a stack, you already select the SSH key. Okay, so as long as that SSH key match with your client machine, you'll log into this node without password. And for other users who don't have your SSH key, they won't be able to log into this node. So this is security for users. Okay, and things we have deployed multiple nodes. You probably want to know what's the IP address and what's the host name of other instances. So our appliance will automatically update the etc host files for you. So if you cat this file, you will see other nodes as well. So for example, now I'm in instance 0. If I do SSH MPI instance 1, I can log into MPI instance 1 without a password, because our appliance already help users to set up the SSH environment automatically, so users don't have to worry about SSH access. Okay, the next step is that now you have the environment, you want to run MPI programs. Next step is to write MPI program. Here we give a very simple example called MPI Hello World. So the left side is the source code of this example. Here we have 4 MPI cores. One is MPI init, which is used to initialize the MPI environment. The second one is MPI com rank, which is used to get the current process rank number, and the MPI com size, which is used to get the how many MPI process has been launched in this MPI job, and then printf, and then the MPI finalize is used to finalize the MPI environment. And then we have a tool called MPI CC in the right side. This shows that how you can combine this source code and generate the binary file. So we can see that through this command, you can get the hello world binary file. Okay, the next thing is things you want to run this hello world program in parallel. So you have to distribute this executable file to other instances. So you can do SCP hello world to MPI instance 1. Okay, so then you can see that in instance 1, the hello world binary file is also there. In MPI instance 0, the hello world file is also there. So now you can launch MPI program parallelly. So we have a tool called MPI run RSH. So in this tool, you need to mention number of processes through this parameter, and then give the host names of the nodes you allocated, and then give the path of the binary file, and then these two MPI process get launched through this command. Through our appliance, all the nodes we will automatically install MPI environment. We will also automatically install the OSU MPI benchmarks suite. So the location is OPD MRP2 libxcc OSU mic benchmarks directory. So through MPI run RSH, you are able to do all different kinds of benchmarking, MPI level benchmarking. So for example, here we show two examples. One is OSU latency, one is OSU bandwidth. The left side is the command of running OSU latency benchmark. The right side is the command of running OSU bandwidth benchmark. So this is the output of latency, this is the output of the bandwidth. So as we can see that through our MRP2 library, you are able to get very good performance on Chameleon Cloud. Okay, let me conclude the presentation here. So in this presentation and tutorial, we provide an overview of Chameleon Cloud and the MRP2 based MPI complex appliance. Currently we have two complex appliances available on Chameleon Cloud. One is used to deploy MPI bare metal cluster. The other one is used to deploy MPI KVM with SR-IOV cluster. And we also provide demos of deploying this MPI bare metal cluster and the KVM with SR-IOV clusters by using these two appliances. As we can see that our appliances can help you to help users to automatically configure the environment, install MPI, install or dependencies, and also configure the MPI environment. And also, for example, if you want to run KVM with SR-IOV, we also automatically deploy the virtual machines for you and configure the virtual machine environment, configure SR-IOV environment for the users. So these are very user-friendly appliances. We also give some examples of how to run MPI programs based on our appliances on Chameleon Cloud. Okay, so these are the web pointers about Now Lab and also the MRP2 project. Please feel free to go to these links and get more information about MRP2. Thank you.